Welcome, everyone, to this webinar on observing agents and how agent observability powers agent evaluation. My name is Harrison. I'm the co-founder CEO. Joined with me is Vivek. Vivek, do you want to do a quick intro?
Yeah, sounds good. Yeah, super excited to be talking about this. I'm Vivek. I work on a bunch of our deep agents work here at LangChain.
Awesome. So it's right at the top of the hour, and I see a bunch of people still joining. So we will probably preamble for a little bit and then jump right into it. Um, but the reason Vivek is here is because today both Anthropic and OpenAI launched things, and testing out these models and seeing how these models are doing is a very topical topic for this webinar, which is all about observability and powering agent evaluation. So the run of show will basically be I'll talk for a little bit in more kind of like a conceptual way around how we think about agent observability here and how we think about that powering agent evals. And I'll probably do that for like 15 or 20 minutes, and then I'll hand it off to Vivek, who will talk for 10 or so minutes in a more hands-on, like practical example of how to apply this to evaluating codecs. Or I guess the new codecs model isn't available via the API, but the old codecs model and the new Opus model. And we'll show off some very practical and hands-on examples of that, and then we'll leave about 10 or so minutes at the end for any questions that folks have. So if you have questions throughout, what we'll be doing is using the Q&A feature, which if on my window, at least in the Zoom box, if I click more, I then see Q&A. And if you put things there, I think you can upvote and downvote questions. And we'll take a look at some of the most popular ones and answer those at the end. Um, I think those are most of the logistics. So before jumping into a few slides that I have to talk about observability and evals, maybe just some level setting. Um, we see these being two of the biggest pain points for kind of like developers building apps. Um, we generally see that observability is probably the place you start, and then evals are maybe the place that you get stuck. Evals are harder. I think observability is more of a there's an easier solution to observability. If you're not familiar with LangSmith, Vivek will show that off later on. And obviously we build tools for all of this, but I'll actually try to talk a little bit about this more conceptually because I think that's more interesting. So observability is relatively easy to set up and see what's happening inside your agent. Evals is harder because I'll talk about this more, but for evals you have to build up your own data sets and you have to build up your own metrics. And so evals is generally when we see people start to think about working with us or working with a solution here. But in our minds, they're very kind of like tightly coupled. And we think observability powers evals in a bunch of interesting ways. So let me share my screen and jump into more of what exactly I mean by that. Cool. So we're going through a big change in the world. Where we're seeing, a few years ago, software was everything that was being built, and now a lot of folks are focused on building LLM apps and increasingly so on agents. And these operate in like pretty like fundamentally different ways, which is giving rise to kind of like fundamentally new challenges and fundamentally new tooling that's needed. So software is deterministic. You write a program, you run it once, you run it twice, it says the same thing each time. LLM apps, LLMs are of course non-deterministic, and they also suffer from prompt sensitivity. But for single call LLM apps, it's still relatively constrained. You call the LLM once with some context, and that context is usually fixed. Plus, you add into the user question, there's some variable there, but that context is passed into the LLM. There's maybe some randomness, there's maybe some sensitivity to user input, and you get back an answer, but it's generally one step. Agents, what happens with agents is you call these LLMs in a loop or in sequences, and these non-deterministic errors or not or differences start to kind of like compound, and you get emergent behavior from these agents as they start to discover and work with tools in a way that you didn't know they could even do. Um, and That's great, but that also means that a lot of the logic of your app no longer just lives purely in kind of like the code. So what I mean by that is if you think about what the code to define an agent looks like, it generally looks like some sort. Let's say you're using a framework like LangChain, or one that you built in house. You probably have this concept of like an agent abstraction that takes in a prompt and a list of tools. And so your app in code looks like this agent class with a prompt and with some tools that are passed to it, and maybe some other things. But that's kind of like what it looks like. But you don't actually know what that does until you run it, because there's so many different ways that that could be interpreted. There's so many different potential inputs to that, because usually the input's some natural language, and so you don't actually know what your agent's going to do until it runs. And so the code no longer kind of like fully documents the core logic of your app. And that's one of the fundamental differences between software and agents in our opinion. You just don't know what the agent will do until you run it. And so that changes things from when things mess up. You go from debugging code to debugging reasoning. So in software, software is deterministic. You've got the code that documents everything pretty perfectly. That's the source of truth. You debug things by identifying failed functions in a stack trace, and then you have these separate sets of APM tools. You also have your separate sets of kind of like evals or test running tools. And generally, your tests and CI are pretty different and pretty disparate from your observability stack and observability solution. Um, and that starts to change a little bit with agents, because now agents are non-deterministic, which means that you don't really know what's going to happen until you run them, which means traces, the observability for them are your sources of truth. That's your source of truth. Um, Debugging is really turns from debugging kind of like stack traces to debugging failures in reasoning. And so like what goes into the LLM, what comes out of it, debugging some of the context engineering around it. And in order to do this well, you need to track threads of conversations, tools, reasoning context, and all of these can also be tied into things like evals and other things like that. So maybe starting from what we think the primitives of agent observability are. And so these are like the core components that power agent observability in kind of like ascending order of complexity. So first you've got runs. This is like a single execution turn. You can think of this as a single LLM call. This already has a bunch of context. It's got the inputs, it's got the outputs. The inputs include things like tools. There's also different parameters like the temperature that goes into it. And then the outputs now, the outputs are not just text anymore. They're a message, and the message could have different components like reasoning and then a final response or tool calls that it makes. And so you've got these individual runs. A trace then consists of basically a list of these runs, and you could have nested traces. So a trace could be like a trace of traces. But this is like a full agent execution from start to finish without any human intervention. And so that human intervention is the piece that separates kind of like traces from threads, because threads are then grouping these traces together where there's human kind of like intervention in between. And so if you think about kind of like a chatbot that you interact with, your message is a form of human intervention. So you send a message, it then runs, the agent might run, call some tools, those tools might get executed. All of these would be individual runs that add up to a trace. It then finishes, you send another human message that kicks off another trace, and so your whole conversation is kind of like this thread. And so that's how we see this kind of like stacking up. And these are the different levels that you really need to observe things at if you want to get a full sense of what's going on in your agents, because no individual piece tells the full story. So this is what runs look like. You can see here that they have the tools, the input prompt, the output. Traces are kind of like, if you this is a screenshot of LangSmith. Traces are best represented by this kind of like waterfall view over here. And in fact, we actually do have a dedicated waterfall view to show off more things, but this is like the sequence of things and the nesting of things. And then threads are these turn components. So how does agent evaluation differ from software evaluation? So we've talked about observability. I now want to talk about evals, and then I'll kind of like tie them together. So first, you're testing reasoning, not code paths. And this is already where there's a tie into observability, because just like there's these different primitives of observability, just like there's these runs, traces, threads, you might want to evaluate reasoning across all of these different kind of like dimensions. So you might want to test a single step of your agent. And this is just like a single LLM call. So if you make one LLM call and you've got this input, like, does it produce the output that you expect? This is what we call kind of like a single step test. It's generally the easiest, it's the fastest. Did the agent make the right decision at this moment in time? A full turn is then like a run of the agent. This is basically, passing in top level user input, letting it run, seeing what the end result is, and then testing that output. And the output could be a message, but it could also be a sequence of messages. It also could be any artifacts that the agent creates along the way. And then multi-turn evals are a step above, where you don't just like call it with one input, you call it with a sequence of inputs. And this brings in some other complications, which we'll talk a little bit more about later on. But now you have to figure out this sequence of inputs. And the second way that so you've got these like new dimensions that you're going to want to test on. And the second thing that differs is that production is really where you discover what to test for online. And this gets back to the fact that you don't really know what agents do until you ship them in production. So one of the best things that we see companies do when they're building agents is ship early and shipped often, even if it's just to a small cohort of users. That's where you really start to see user behavior and user inputs, and that's where you start to build up these test sets that you're going to test for later on along the way. So diving a little bit more into kind of like single step evaluation. So this is like user input, you run it once. You don't keep on running the sequence, you just call the model kind of like once. This is good for validating individual agents in isolation. So it's good for if you have some rules or you have some logic that if every time a user comes in requesting a meeting, the first thing you need to do is check the calendar. This is a good check to see, hey, is the first thing the agent does it call the like check calendar tool? Um, Generally, these are fast to execute, and they generally have clear kind of like pass fail criteria. Full turn evaluations keep this running. So the user puts in a message, the AI calls the tool, you keep on looping until the AI decides that it's done. And so this validates the complete agent runs from input to final output. In an example might be if you're using a coding agent, you'd let it run for a while. Did the coding agent produce working tested code? The benefits of this are that it includes kind of like real behavior of the agent along the trajectory, so multiple things in a row, including kind of like tool usage and state changes, so like changes to the file system. And this is both good and bad, but it's definitely more kind of like realistic. And then if we go to the multi-turn, this is what I was talking about validating threads across multiple conversation turns. And there you can do things like test whether it remembers previous things that were mentioned in previous turns, or test if that it asks like appropriate follow-up questions and then does information with that. The pros of this is this is the most realistic test of production behavior, because most agents have some kind of like conversational or human in the loop aspect to them. The downside is this is quite hard to do, because the second user message might totally depend on what the first user message response is. And so you need some sort of checks to make sure that it's aligned along the way. So generally, when we see people running this, we see that they run this step, they get the output, they like check that it's within some kind of like constraints, and then if it is, and they can guess the next user input, they put pass in another one. And so just to maybe summarize some of the pros and cons, and we see people doing these, we see people doing different variants of these. It's not like there's any right one. You can also and absolutely should do multiple of these, but like the single step ones are easiest to define kind of like metrics for. The downside here is that if you change the internals of your agent, these go out of date pretty easily. So actually these probably aren't the first thing we see people build. We probably see them build things when they're a little bit more confident in their architecture. Traces like a full turn, this is what we see people build first, usually because it's really easy to define inputs for these. The downside is it's harder to define metrics for these. Um, and so oftentimes we actually see that to start, people just create like 5 or 10 example inputs. They're judging things by eye, so they don't even have metrics, but they're running those by eye. And then when they start to settle on an architecture, that's when they maybe test like, hey, is it doing this routing correct at a particular step or something like that. And then threads are again these multi-turn ones. The pros of this are some of the most realistic user behavior, but this is actually pretty hard to define things for. There's also different times that people should be testing agents. And traces power all of these, like observability powers all of these different methods of evaluation. So offline evals is basically building up a data set, running your agent over that data set, or LLM over that data set, and then getting a score and trying to improve the score there. And so this happens before you ship to production, and it's good for catching regressions or benchmarking. Online evals happen after the agent finishes running. And so the agent runs, it sends a trace to LangSmith. On LangSmith's side will run some online evals, and this is really good for flagging issues in production because this is real production traffic. And then ad hoc is when you want to look at your production data and kind of like score them along some dimension, but it's maybe like a one-off thing that you're curious about. And so this is really good for exploratory data analysis. And so, for example, we have chat LangChain, which is chat over our docs. And I wanted to see what types of questions people were asking about LangGraph. And so I ran an evaluator to score runs to see whether the question was about LangGraph or not. And then once it was, I could look at those. And so there's all these different types of evaluations. You run them at different points. You judge different things. How does agent observability power these different types? So first, traces power manually debugging. So I would absolutely call like manual debugging as a form of like manual ad hoc kind of like evaluation. And traces power this because you can basically just like look at the trace, see what went wrong, open it. The trace has all the individual runs, so you can go to a particular run, open it up in a playground, and then play around with it there and get a sense for what changed. I have this running every time I run an agent locally. I don't look at it 95% of the time, but the 5% I do, it's super valuable to have that trace. You can also debug production issues this way because they're all sending up traces. Traces power offline evaluation. So the offline evaluation is when you build up a data set and then run benchmarking runs over it. And oftentimes these data sets are built from production traces because again, you don't actually know what you should be testing for until you see how users are using it. And so you ship your agent, you get some production traces, the agent runs over it, and then you build up a data set. And so the workflow usually is like I'm logging everything to LangSmith. The user will say, hey, this went wrong. The agent gave a bad response, something like that. I'll go find the production trace in LangSmith. I'll see like where it failed because this trace has a bunch of runs. And so maybe I want to test the whole trace, but maybe I want to test a particular point. And so I'll find kind of like the state of the agent at that failure point because tracing will track all the inputs and outputs so you know the state. And then that state becomes the test case. And then I'll go into my offline eval cycle where I'll make some changes to a prompt, run the prompt over, fix it, and try to fix it up that way. Traces power online evals. So these are traces that are coming into production. Online evals run over these traces. One big difference here compared to offline evals is that in online evals, you obviously don't have the ground truth. So the types of evaluators that you're running are pretty different. What types of things can you check for though? Even if you don't have ground truth, you can flag for unusual tool call patterns. So you can check to see if the LLM's calling like the same tool a bunch in a row. Vivek, maybe you can touch on this later. I don't think you did this in online evals, but I think you actually did something kind of like in the loop when you were trying to improve our agent harness.
Exactly,
Um,
yeah.
yeah. Do you maybe want to tell that story? Because I actually think that's pretty cool.
Yeah, I definitely can. So like a quick sneak peek and we'll talk in like 10 minutes. But so when we're trying to make our agents better, there's basically like what Harrison's saying, like we'll measure every single thing they're doing and we can see all the steps. So when we dig into those, like as a team, as humans, or we have an agent look at them, we observe these like weird pathologies that agents sort of trip up on. One thing that's really common with these reasoning models is that although they think through a problem a lot, they like will get down this rabbit hole where they'll just keep editing the same thing over and over again. Often it's a file. And like usually when that happens, like we see the result is like a failure. It's just like spiraling out of control. So like we have deterministic hooks that we can put into like our agent harness framework that detects like, hey, like you edited this file like 5, 6 times. Take a step back and reevaluate your decision or like go plan a little bit more. So like we basically use traces to observe these pathologies, and then like we inject our experiments to try to make the harness better, and then we reevaluate and see if that's actually making it better.
And so you can do something like that as online evals, and it won't inject it back into the live running of the agent, but you can use it to fix up things after the fact. And this is really, I was actually very excited to hear this because, as I mentioned, one of the things about evals is that it's quite hard to build your own evals. Like you have to build your own data sets, and you generally have to build your own metrics, because agents do different things, and business logics might want to test them in different ways. But this is a pretty generic chest that we can kind of like add off the shelf and kind of like give you as part of LangSmith. And so I was pretty excited. It's not in LangSmith yet, but this made me think that we should add it into LangSmith as kind of like an off-the-shelf evaluator. Um, Other things you can test for efficiency monitoring, so kind of like test whether the LLMs, giving way too big outputs or way too small outputs. Quality scoring, if you're able to test, if we have some that can detect kind of like hallucinations, and so you can check, hey, does the output contain anything that's not explicitly in some of the input context? And then also failure alerts, and this can look like this is actually very useful for some of the thread level evals when you have the whole conversation. But if the user says something like, no, that's wrong, or things like that, you can actually detect in their conversation if things are messing up and not have them have to report it directly. Ad hoc insights is another thing that traces power. And so this is basically this is one of the cooler things we have in LangSmith. You send us all your traces, and then you can run insights analysis over it and ask questions like, how are people using my agents? Where and why are users getting frustrated? And you can, and then we cluster those, and then you can compare kind of and then we show you metrics for each cluster, and you can compare different clusters across those dimensions. And so, yeah, one of the core theses that we're really realizing is that agent observability powers a bunch of other things that is a little bit different than in software. Like in software, observability kind of sits to the side. Your app like emits metrics, and you go and look at those, and you go and look at logs, and you debug it, but it's a little bit to the side. With agents, it's much more part of the overall kind of like loop of application development. Before going to questions, I want to switch over to Vivek to do the kind of like deep dive into some of the Opus and Codex stuff, which was a late addition, which is why we don't have a slide for it.
Yeah, awesome. Thanks, Harrison. Let me get my screen up as well. Cool, awesome. So, real quick, over the next 10 minutes, there's a few things that I want to cover that basically takes a lot of like Harrison's good content in the slides and goes over like what is the actual workflow that our team is doing every day when we're trying to make our agent better, basically. So, the team that I work on, so I lead a bunch of stuff for our library called Deep Agents. So, let me show you that. That is right here. Go check it out. Basically, what this is, it's our harness, which allows you to take any model and then like customize it for your task, right? So like write your own prompts, like add your own tools, like add your own hooks, like if you observe these pathologies as well. And what our team does is we want to make that the best place to customize your harness, but then also a great out of the box experience for coding. And the way that we actually do that is we go and we look at existing benchmarks, existing evals, and we try to make them better. So one of the ones that all of the frontier labs they test on, it's called Terminal Bench and Terminal Bench 2.0. So actually, I have the releases out here for Codex and Opus 4.6. So you can see like this is one of the ones that they run, and there's a really big increase from GPT 5.2 Codex to GPT 5.3 Codex. So like immediately for us, we're like, okay, that's something we need to take a look at. That's something we need to test in our harness to make sure that the user experience out of the box is amazing. And that means that hopefully the customizability experience will be amazing if you need to tweak it for something. Same thing with Opus. This one's available in API immediately. So like was able to get it running ASAP essentially. And before jumping to the traces, I'll just show you like one more thing. Basically, like our mental model of the day to day for how are we going to make our harness better and like what are some key levers basically that we're looking at. So we have the model, right? So that's like pick Codex, pick Opus, pick Sonnet, pick Haiku if you need to run a little bit quicker. And then we have the harness, which was what we provide. And that's tons of sort of opinionated batteries included built-ins that you can tweak and change, but things that we think are really helpful. So sort of like built-in prompts for hey, like if you're approaching this problem in this way, like planning in this way is really helpful. Using the file system in this way is really helpful. Delegating to subagents is really helpful to keep your main context clean and to speed up work, right? Another thing that's very particular often about these frontier lab sort of benchmarks is environment context, but this has like a really good analogy to your day-to-day maybe coding, if that's what you're using coding agents for. It's environment context can be what's in my file system? How is my repository structured? What are the coding guidelines that my team is following, right? All of this stuff, you want that maybe almost auto-injected into the model context because that's just a place of error that you might introduce if every time you're doing a task, it's searching for this, right? So these are sort of like priors that we try to bake into the model and we bake into the harness, essentially. And then there's middlewares, which I'll show you, and then sub agents, which is this one I'm really excited about. I actually just tweeted about it, which is in deep agents in the harness, you're not limited to one model provider or one model. Like use them all together. Find what's the best approach for your task in particular. I'm gonna, when Codex is out, Codex 5.3, I'm gonna use Codex 5.3 and Opus 4.6 together to see if we can like really push the frontier of like how good we can do on our coding tasks. So great. Just like a quick primer. Now I'm going to dive into LangSmith to show you kind of how I manually look at traces. And then also, I'm pretty excited to show you something else, which is how we do like automated evaluations, like automated parsing of traces, understanding traces at like a really big scale. So like 100 tasks at once, like 200, 300 tasks at once. So I have like a few up already. So you can see this is Open 4.6, Opus 4.6. So Harrison DM'd me like immediately. I went. I'm like, okay, let's get another run going for Opus 4.6, which is awesome. Let me maybe just show you like what terminal bench is, like so you can get a feel of the task, and then also some of the things that I look for as we're trying to make the harness better, right? So I said like I might tweak prompts, I might tweak the middlewares, I might tweak all of that stuff. So this is the task description, right? So this is auto injected from terminal bench into the model. Looks like a human message, but just think that like someone is giving this task to the agent, right? So it's like complete this implementation to find the dominant eigenvalue, eigenvector, and like this is the location of it basically, right? So it's like setting the scene. Um, the immediate thing actually that I look for is what is the first step that the model made, which is let me start by reading the existing files to understand the problem. Like, why do I actually care about that? I'll tell you it's because I wrote like a very detailed prompt with the team about how should you actually start doing things, right? So like I have this thing like you are a deep agent, so like powerful coding AI agent, like when to stop basically. You're working autonomously, right? So these are really important sort of like levers that I look at. In particular for these offline evals, there's one thing that comes up over and over again, which is there's no human to help the model, right? But the model doesn't know that. So sometimes it will like prematurely stop, or it will ask an agent, or it'll ask a human, can you like respond to me or something, right? And as we're moving into the regime of give agent a task, it works almost async, and then I come and review. That's not something that you want in like your agent behavior, basically. So how do we do that? Like maybe I put in the prompt to say like, hey, do not stop until like all these things are done. What's another way that we enforce that? I'll show you here. So like I talked a little bit about middlewares, right? Which was think of middlewares as basically like hooks around model actions that execute like sort of deterministic behavior. So here I have a few. So I have right here I have a checklist basically that I give it. Let me scroll down. Um, cool. So I basically say efficient verification, right? So in coding agents in particular, verification is like really crucial because code is one of those domains where it's actually verifiable. I can actually generate tests. I can actually do linting. I can actually like use our coding best practices, and the model can get feedback from those steps to say, hey, I'm doing this well or I'm not doing this well. But another thing that we can do is that if the model tries to finish, I can call these sort of like pre-completion checklist middlewares, basically that says like models like, hey, I'm done. And I'm like, before you say you're done, can you go back and look at the checklist file to make sure that you've actually done each of these steps, right? If you're doing this as part of a PR workflow, then like maybe you'll actually like run those things on like on your GitHub Actions, right? And that'll be feedback to the model. So this is like actually what I'm looking at every day, which is what was the first action that the model did? Like what was the second action that the model did? And then I go back and maybe the thing that I'm like really excited to share as well, which is this is one trace. Terminal Bench has 89 tasks, right? I'm running this for multiple models. So I'm just one person. There is no way that I'm going to be able to read all of this data, right? That's when these things come in, like generating reports from your tracing data, which is super valuable. But you can't start on this journey if you don't start sort of like tracing your projects from the start, right? Like this is only possible because every time I do a deep agent run, that all gets automatically logged to my LangSmith project. And then later I can work with the team to say like, hey, like what are we interested in? Like what are these new things we want to try in the harness? Um, what I have here is I'll show you this. So like we'll probably be releasing this as an example soon, but I have this skill, which is a LangSmith trace analyzer skill. What this does, it uses LangSmith fetch. And what LangSmith fetch basically does is it pulls the traces for my project into like my local environment. And then I have particular markdown files that tell it, hey, if we're doing a terminal bench analysis, what I want you to do is I want you to group all of the failure modes together. And then I want you to propose potential fixes that we could do. And then like our team will go and like we'll actually like human review some of those. And this all happens in parallel. And like what do we get out of that? We get a report basically. And this report is a good like growing artifact that we can share with the team to say, hey, this is how research is progressing. This is like how well we're doing basically. So I'll show you one from yesterday that I made. Of course, today everything changes with new model releases, but we ran this on Codex 5.2 extra high, and we got 65.2 pass rate. Great, sounds good. That would have actually been number one yesterday, right? With the new releases that came out. So I'm gonna rerun on Opus today and like see how much better we can get, right? 65.2 would have been here basically. So this is like great feedback for the team. And then what does it do? It goes and like it categorizes the errors. Like, hey, like these are the mistakes basically that we were making. The other thing that I really like is it's not just agent logical errors, right? I can read these traces and I can say, hey, like the agent is getting confused. It's also sometimes like infrastructure errors. Like these are things that are out of your control. You might be deploying your model somewhere and you're like, hey, it's just timed out for some reason, but it might not be your fault, like the agent's fault. It might be, hey, this sandbox died or something. You know, these are all basically feedback loops that we can use. And this is how our team uses it every day. We put everything into LangSmith. I take a look at them, I read them, I update my prompts, I update my tool descriptions, I might try using multiple models. And then when I have a critical mass, I'll go and I'll run this workflow, which generates this report using our agent skills. Like I use a deep agent to generate this, and then we'll review with the team. And it's a very scientific process. It's basically there's a vibes way of doing it, which is awesome as well. But then there's sort of this more scientific way when I track everything in LangSmith and try to improve things over time. So yeah, definitely will be a follow-up soon because we're gonna have an Opus 4.6 run going probably in a couple hours. And yeah, excited to share some of the stuff and release the skills and answer questions.
Cool. Awesome. So yeah, hopefully that was a good mix of some kind of like conceptual ways we think about things, but also some hands-on stuff. I think we got about 15 minutes left, so now we can jump into some of the questions. I see that there's 10 open. Um, what is your intuitions on when folks will have continuous pipelines, observability to eval to post-training and prod, as you have already made good progress on observability and evals, and then kind of like a follow-up to that, or do you see test time compute is the way to go? I mean, I'll take a stab here, and then I think Vivek, you've thought about this a bunch as well. And actually, there is literally a Slack thread on this that I tagged Vivek in, actually as he was giving his talk. I mean, the TLDR is, I think, in some place. So I think part of this is very similar to memory. Like I view memory as a way of kind of like improving over time, just like post training would be. And so yeah, I think that would probably fall under the test time compute part. Memory is still memory's still pretty new. I don't think it's just memory's just a system, and I don't think there's anything more complex than that. And it's just a system of setting up these setting up all this pipelining of data because basically you have to take these traces and you have to like do something with them and then you have to test whether it's good enough or maybe you don't test whether and do something with them like change the prompt then you test it then you commit it and release it and it's kind of just setting up that pipeline having that confidence in those automated tests or kind of like not caring about like automated tests. I think we see very basic aspects of memory being present already, but still very early on. But yeah, I think there are people doing this today is what I would say, and but it's not post training. It's kind of like test time compute. That would be my answer, Vivek. I don't know if you have a different one or
No, I agree. Like we're generally very interested in memory. There's like maybe one thing I'll add, which is it's not post trading in terms of the RL post training, but there is like a whole other class of training approaches, which is like reflective optimization at scale, which is basically like take a bunch of traces which have signal in them, distill the learnings from them, and then update the things that aren't the weights that are still incredibly important for like model performance. So that's like everything in the harness basically. And kind of like from our results, that helps a ton as well. You could take a model and you can improve the harness, you can get even bigger scales of improvement than you would have got from maybe switching the model. So yeah.
Are you using sandboxes for insights at scale? And if yes, any insights on the trade-offs and which one you're currently are the best ones? For our insights job right now, we're actually not using sandboxes. So we're using deep agents. Deep agents comes with this concept of like a virtual file system, which lets us do kind of like manipulation of text data without using a sandbox. Um, we do use sandboxes in other places, generally pretty bullish on sandboxes. I think they will be a super important part of the infra stack. I don't have a super strong opinion on any of the trade-offs or which one's best. Vivek, anything to add there?
No, I think yeah, covered it.
Cool. Um, as we see this huge shift in application development, do you see agentic being looked after by operations slash DevOps slash SRE teams, or will a new role for agentic operations emerge? Um, Really good question. I think there will be a new role that emerges. I think when you're an SRE is kind of like looking at like software errors and system errors, and I think oftentimes agentic ops, um, it is subject matter experts that are looking at something and saying, "Hey, like, yeah, this is an error because the agent said X and it should have said Y." Like those are like don't get me wrong, like DevOps will still be important for parts of the agent, but for the agent logic, like that is a different folks. It's subject matter experts. Are traditional Ollie skills transferable? Probably not for this part. I think this is like I mean like some of like the maybe like first principles part of like being really diligent and like tracking down stuff, absolutely. But like I think like the hard skills, this is about being a subject matter expert. Um, and then follow up for this, how prevalent are agentic deployments today? Are we in the future or are folks still experimenting? Vivek, you've talked with a lot of people building on top of deep agents, which I think is our most in the future agentic thing. What are people building there?
Yeah, yeah. I think we are in the future, and the future is like definitely accelerating and growing. Like more and more people are building sort of agentic or agentic adjacent apps, right? So there's a few things that keep coming up that a lot of teams are deploying with. So one is these sort of like customer service use cases. Anything where there's sort of a workflow can almost capture it, but there are sort of decision steps and like context you need to gather and like more autonomy that you need to build. That's one place that we're seeing it's just easier to jump into agents rather than like enumerating everything in the workflow. So teams just embrace it because more and more the agents are getting more reliable, they're getting smarter. Customer service is one. There's also a bunch of interesting ones across finance. And like recently I've been seeing them in like biology as well. Places where you have to crunch a bunch of data and then make decisions on it or give reports to decision makers. Those are generally good applications that we're seeing built on deep agents that people are like using and deploying today.
How many tests would you recommend to run? How many times to call it a pass, given the systems are probabilistic? Um, I don't know if I have a super good heuristic here. I think it probably depends on how high of confidence you want. Vivek, you've been doing a bunch of terminal bench kind of like hacking. What have you seen in terms of variability between runs?
Yeah, it depends on the data set, not the fun answer, but I think like you do want to have some sort of like standard error confidence interval. People usually run it 3 to 5 times, I would say. I would say for all use cases, you shouldn't do that, but I would say like it actually maybe bifurcate them mentally, which is a lot of these like long horizon agent traces where there's one step that can maybe derail you. It's worth running it a few times just because there's a large error space there, and then maybe more like simple classification ones, maybe 1 or 2 times is good. But good question. I think also evolving depending on your industry.
Cool. Um, how about leveraging observability to increase the security of agentic applications? This is something we've talked about a little bit. So, some thoughts here. I mean, like, um, I think, yeah, once you have these traces, I think you can run things over them either kind of like online or ad hoc to test for kind of like malicious kind of like activity. So examples might be like testing for prompt injections, testing for indirect prompt injections, where like your agent calls a tool and the tool returns something that has been prompt injected. Um, Testing whether there's API keys that are being leaked or something like that. I think all of these are totally doable with our current infrastructure. This came up kind of recently, so we don't have any kind of like good demos or examples of this. If this is interesting, like please reach out and we would love to work on this. Vivek, anything else to add here?
No, I think you covered it. There's probably a lot of stuff at both the model layer and like the infra layer that you can do. Like prompt injection is one. There's like guardrails with LLMs can try to catch some of these like security injections. But yeah, I think like Harrison said, if there's any particular thing, like our team is really happy to take a look at it. It's really interesting.
Um, what is the best slash recommended way to get this integrated into a new agent development workflow? So maybe a few thoughts here. Like step one, I would say is like just set up tracing. Like I think that should be the bare kind, like that's the first step. If you're asking like how to do that, we have a bunch of integrations with a bunch of frameworks out there. Not only kind of like LangChain, LangGraph, but Crew AI, OpenAI agents, OpenAI SDK directly. So we have a ton of integrations out there. We also support OTel. And so if you're already instrumenting your code with OTel or you're familiar with OTel, you can use OTel for that. And then we also have a custom SDK for kind of like tracing. And so yeah, my rec would be kind of like setup, tracing. Those three methods are the most common ways we see people do it. Vivek, after they set up tracing, what would you like? What would be the two or three things you do after that?
Yeah, so I think like Harrison and I talk about this a lot, but just like send me the trace. That's like the number one thing. So like once it's on, I'll tell you like what our workflow is, couple steps. So it's use the agent to do something that's sort of like meaningful to your team. And it when I say like make your first like eval, it can literally just be like, hey, I do this thing every single day. Like I'm trying to code this new feature. I'll just go do that. You need to like populate your data to like reflect on something. So I'll use it for a task. Once I get a critical mass of honestly like five or something, I'll review it. So like I'll either manually go through it, if especially if something went wrong in that session, I'll go and review it, and then I'll try to aggregate thoughts over like the 5 to 10, and then try to make improvements, basically. So it's like store them, and that gives you the opportunity to like improve the thing you want. It could be switch your model, switch your prompts, switch your tools, like switch one of those things, but get the data and then look at it, basically.
Okay, maybe last question, and then I will go rapid fire through some of the ones here that are quicker. Have you tried any prompt optimization techniques to improve agent slash deep agent prompts? Vivek, this is all you've been doing for the last few days. You want to take this one?
Yeah. Yes. So there's a huge class of research which is like prompt optimization, like you might have heard of JEPA. That's maybe where this question is coming from. Yeah, basically the flow that I shared is our most common flow. It's like a form of JEPA, basically, but uh, take a bunch of traces, distill those insights. I will add one thing, which is human priors. Injecting those into your prompts is incredibly valuable as well. Like I won't just like let the agent look at all the traces. I'll be like, this is what our team thinks that you should do to improve them. Like take that into account as well and then improve and then rerun. The other thing I'll just roughly add is skills. We support that natively in deep agents. This is like a fantastic way to package more like semantic actions, and like skills basically are prompts. Like they get injected into your system as prompts, they're specializations. If I see something coming up over and over again, I make it into a skill essentially, and then go from there. So I think there's I could talk for another hour about it, but like those are the two sort of like main ways that we've been doing it.
Cool. And then I'm gonna maybe go rapid fire through as many as I can in the next 3 or so minutes. Any plan or roadmap for native gateway or proxy layer? No. Is there an API to turn trace on and off for different parts of the agent? Yes, there's a few different ways. Can ask on a forum or GitHub, and we'll give code snippets there. Any kind of like sensitivity analysis or cost simulator tool. We have all the data around cost and performance there. I don't think we try to give you that data and let you make the trade-offs and you do the forecast. We don't have anything built in. Can you filter the traces just on data exchanges? Um, Possibly. It depend. I don't fully understand this question. You can add a bunch of metadata and tags to traces, and so if you can't do it natively, that would be the manual way to do it. Can you use middlewares for tracing? You can, but you don't need to. Well, it depends. If you're asking about LangChain middlewares, we already do it automatically, so you don't need to use it there. If you're talking about like middlewares and hooks and like Claude Code, then yes. What happens when tools have LLM calls we are evaluating? uh, uh, what happens when tools have LLM calls? How are we evaluating? You evaluate the LLM calls that are part of the tool, or the tool itself, and end to end. It's a combination of kind of all of them. We have data residency requirements. Is LangSmith a server Australia? Is LangSmith server available in Australia? Not yet, but we do have a hybrid deployment and self-hosted option. What features are you seeing getting used the most and least in LangSmith at the moment? Most is absolutely tracing, probably followed by like prompt playground and insights agent. Least is maybe some of the alerting and monitoring stuff. That's a big focus for us in the upcoming few months. What is your take on RLM, and will LangSmith evolve to support RLM using threads and traces? Uh, yeah, I think RLM is very similar to a lot of the coding agents out there. I think we already support it pretty well. Do you plan on adding retry and fallback model settings for prompts? Yes, we absolutely want to beef up our prompt hub support. If you have specific asks there, I think the retry and fallback is on a roadmap. But if you have specific asks there, please get in touch. We would love to chat. Um, I there's more coming in than I can possibly kind of like answer, but both Vivek and I are terminally online on Twitter, so please message us, shoot us a tweet. We'd love to chat about all of this. All these questions have been great. Um, if there's anything I can leave you guys with, it would just be that observability powers all of this. And so I would set up observability and tracing specifically. Like when I say observability, I think sometime in software you think like Datadog and all those production logs. No, no, no. Like observability for agents comes in way earlier. Like I would set that up. Even like if you're not using LangSmith, that's fine. Just like set it up. You're gonna have a happier kind of like life. And obviously you should use LangSmith. Um, any last words of wisdom from you, Vivek?
No, I think you covered it.
Cool. All right. Awesome. Thank you guys all for coming. We'll do more of these. Send us any questions on Twitter.
Sweet. Everyone.